Hey everyone, welcome to Intro to LayerZero. My name is Adel. I'm an integrations engineer at LayerZero Labs. You can follow me over there on Twitter. I know I don't look like my profile picture, but that's me. Cool. So let's start off with what LayerZero is. So LayerZero is basically an interoperability protocol that lets you send messages across from one chain to the other. To first think about it, let's take a step back. How did we get to this point of cross-chain and where it kind of just started? So initially, when people started building applications on the blockchain, they started thinking about which blockchain they wanted to deploy apps on. So if they want to deploy stuff on Bitcoin, I guess you can do on Bitcoin, but like if you want to deploy stuff on smart contracts on Ethereum, you can do that. There's better security there. But now it's getting expensive there. So that's when L2s came up. So we had Optimism, base chain, all that to make things simpler. So then people were deploying all these applications and all those different blockchains. The problem is now that things are kind of like staggered all over the place, there was a need to start like messaging across. We found that over time that because of new chains coming up, liquidity in different chains, like right now Abstract is really big for gaming, and people who are made games in different chains, they want to go to Abstract. Or if you are in like Hyperliquid and you want liquidity from Hyperliquid. So people started expanding their assets or tokens or whatever to different chains. As you can see, the data shows that the more apps that are coming out, they're actually being deployed in more than one chain. And so how does cross-chain state transfer work? Normally, you have two blockchains. Let's say there's Linea on this side and Ethereum on the other side. For you to transfer stuff like value across, you have to first debit it on your side. So you have to either lock it up or burn it on the destination side. And then on the receiving end, it has to be sent to the receiver. So it's kind of credited over. But how does this actually happen between two blockchains? Well, the old way of doing things were monolithic bridge security. So you would have some sort of centralized service over here, right? This was normally like a custodian or like some centralized service there, which would store all that value. So if let's say you're transferring ETH over, that ETH would be stored here and then kind of credited over to the destination side. Now, we all know that's kind of bad, because what if things go wrong here? So if for whatever reason, they found a vulnerability and some malicious actor is able to take over, then they can actually basically just call LZ, like the receive end, as many times as they want, and like basically take all the liquidity out of the protocol. And that's not new. We've seen this happen. So 4 of the 5 largest hacks in crypto has been in this because of this. We had all these monolithic structures where millions and millions of dollars, as you can see, there are hundreds of millions of dollars that were taken out of the ecosystem through exploits, right? So that's where LayerZero kind of came in. So we kind of started off with these early isolated chains. Then we had this bridging infrastructure, which eventually faced there was a high risk of exploits there, right? So 2.1 billion that was kind of just gone. And that's kind of where LayerZero stepped in. We came in with this modular approach. So we wanted security to be configurable. We wanted the endpoints to be permissionless and immutable. And right now, it is the most widely adopted interop solution in the market. So you can think about LayerZero. And it's basically as an infrastructure, a bridge infrastructure that's built upon 3 principles. The first one is that it is permissionless. So our endpoint protocols, anyone can call those contracts. We have security layers called DVNs. Anyone can host those contracts or like those DVNs. We don't centralize it. We don't own anything here. The second part is that it's censorship resistant. So we can't stop anyone from interacting with the endpoint contracts. Anyone can just call it. And finally, it's immutable. Our endpoint contracts are connected with different chains, and it's fully immutable. We won't be upgrading that anytime soon. So we can start thinking about this with our first application that we kind of formalized. We call it the OApp. OApp is the simplest primitive that we have. The idea of an OApp is that you can send any bits of data from one chain to the other. It could be anything. It could just be a message that says hi. So we basically ABI encoded in one chain and ABI decoded on the other end. So let's look at quickly and the send and message workflow, right? So in chain A over there, you'll have your message. It could be any data that you basically could send alongside with some configuration. So in that, or the metadata, I guess the params you're passing in would be the destination chain you want to send it to and some config. The config over here kind of like helps us figure out what the security stack is going to look like and what the executor is. And let's jump into the verification. So the security stack over here, this is a modular security stack that's not owned by us. We call these DVNs. Any third party can host a DVN, and that basically verifies like the payload hash that's being sent across. And you can add as many as you want or as little as you want based on the amount of security. So this is how we get past the problem with a monolithic structure. It's no longer monolithic. There's multiple DVNs. Once that's kind of done, the verification, we have this executor. Again, this is a permissionless executor. Anyone can host it, so anyone can call that to do the receiving logic. So the executor is kind of like responsible for calling the receive functionality on the destination chain. So that's where like things get credited. So Omnichain transfers, this is kind of where we went after. Just real quick, okay. Yeah, so building on top of that logic, what I explained, OApps, being able to send messages across, we realized if you can send messages across, you can basically encode everything you need for ERC20 tokens, and basically you build the OFT standard. And the OFT standard essentially lets you just like send tokens across using the same concept on the source side. When you're sending, you burn the token, and on the destination side, it is credited, so it is minted on that destination chain. So we essentially simplified the entire Omnichain transfers, again, with that modular security you see in the middle. Like there's no central service. One of the DVNs could fail. There's 3 other DVNs, or like however you configure it. You can also have optional DVNs, and we have a lot of other customization that you can do, such as number of confirmations and all that. Cool. Okay, so from all that, we kind of have like this whole stack that we built. This is, you can have any application in any of this space, if it's like a gaming, NFT, social. And we have a bunch of contract standards. The OFT standards is for like tokens. We have the OApp for very simple messaging. And we also have ONFT that's for sending NFTs back and forth with like, and this is kind of how we look. We have all the custom configurations on the side that makes security one of the most important part of this protocol. Cool. I'm going to skip this. So one of the new things that I'm going to talk about right now real quick is LZ Read. In our prizes right now for our hackathon, we have 3 tracks. The first track is LZ Compose. I'm going to quickly talk about LZ Compose real quick here. LZ Compose is this idea of you send a message from one chain to the other chain, but the time it gets to the destination chain, if you want to do some action on that chain. So let's say you were to send tokens across from base to ETH, but on ETH you want to do a swap, or you want to deposit that token on a different, on a vault or something. So that's kind of like where LZ Compose comes into play. It's like it's a send and then action. So that's where one of our prizes is right now. That's one of the main tracks we're looking for. And finally, the second one is LZ Read. And that's a new primitive that we kind of made, which is kind of working with the same security logic we had in the other ones. But basically, you can query data from any other chain. And yeah, cross-chain querying for any like public on-chain data. That's like pretty much should sum up like this entire flow here. And I'm going to jump straight into a demo. Okay. So I want to make sure it's like super easy for you guys to kind of like start. So okay, maybe I'll just do this. So to get started with our documentation, you guys just go to Google, search up LayerZero docs. You'll be taken to this page where everything is really. So just go to EVM because it's the easiest setup, and we'll go just straight to the OFT case, or actually just even the CLI setup guide here. I think that should happen. So you kind of just want this guy over here, and essentially here you can go to like your terminal and just do npx create LZ app. And that will let you like make the, that's how I do this, right? Where was that? Sure. Okay, and then you can just like name your app over here, like let's say app, and you can choose which standard you want to work with. So we could just do like an OFT or an OApp. For now, I'll just select OFT, and then the package manager is PNPM. So let's go with that. It will install dependencies and all that. For the sake of this demo, I'm going to kind of like skip that a little bit. I'll let this happen, but I'm going to go to what it will look like after you've kind of deployed. You'll get like a page that will sort of kind of look like this. Let me zoom in a bit maybe so it makes sense. Okay, ignore my cursor questions on the side. I don't use AI to code. I know. Yeah, so you will have the OFT contract. This is the OFT standard that kind of just comes within, and this is what's kind of will be deployed on different chains. So here I'm just forcing a mint over here, and then the most important parts, once you have this kind of ready, I would say just go over there, look at the README and just open preview. You're able to follow all the instructions we have to kind of set it up and going. So you'll notice the first thing you have to do is make sure everything's installed. Then you're like compiling it. And we have a bunch of tests here as well, which I can quickly run through it really fast. But we have simple tests that like Foundry tests that will explain how the send OFT is kind of working. And you can see how you have to construct a send param here with like the destination and all that. Again, come to our booths after and we'll kind of explain how all that kind of work here. And that explains how like a send logic works. And there's also another example which explains how the compose logic works over here. But we can dig into that a bit later. But essentially, if we go back to the README, so the most important part is once you have all that kind of ready, the first thing you want to do is have your env file. I'm not going to open that for obvious reasons. My private keys are all going to be exposed on YouTube. But yeah, so first of all, based on the chains you want to deploy to, you want to go to the hard hat config. You want to put in the networks over here in this kind of format. I'm not going to be doing like a live demo right now, but you basically like specify like the networks. We have this concept of like endpoint ID, so which from Sepolia to like let's say Avalanche, and you can just put in your RPC URLs over here. And once you do that, you run LZ npx hardhack LZ deploy. This will let you deploy the OFT contracts on the different destinations. And then finally, we need to wire up the contracts. So to do that, we will just keep going down. Yeah, so once you set up the hard hat with all the different chains you want to be on, you simply invoke the npx hardhack LZ OApp config init, pass in the contract name and the OApp config, I think. Actually, wait, no, maybe not. Maybe you don't do this. You'll come up with the LayerZero config file over here. We have this concept of a simplified config generator. You basically pass in the contract name of the contract you're going to deploy. In our case, that contract's actually in the contracts my OFT over here. And yeah, you define the endpoints, kind of have the contract set up. You don't need this. Yeah, but basically just go into the two-way config path and have the chains you wanted in place. And we simply just want to run this after. So if I go back to the README, you will basically want to run this command. So the npx hardhat wire command, this will wire up the two chains together. Your OFT can actually be sent across now. Yeah, I'm not doing the live demo to completely show you that whole thing, but this will basically allow you to do that. And after you kind of do that, you have like the send task that if it's not here, you'll be able to find it on this guy. We have a calling send, which kind of gives you like a hard hat task. So, and that's just how you invoke the send command. And in my case, I could probably just do this. Yeah, so you can just call the send command using a param like this after you invoke that over, and this will let you send, let's say, 10 mock OFT token from one chain to the other. Right now, it's failing for reasons that I don't want to go into. Oh yeah, insufficient funds. Okay, maybe I've used up all of it. Oh, actually, no, I just changed my EVM keys. But yeah, essentially, this is how you would simply set up like an OFT, a very simplified use case of LayerZero. And yeah, with that, I think I wanted to go through most of what I wanted from this. But yeah, so for the hackathon, the main important things that I guess you guys should focus on is how you can use compose logic, which is a bit more of the more advanced use cases, or how you can use the LZ read. Again, we do have the general track. The general track is like if you were building a simple OFT for whatever, like to send things across, or ONFT. Yeah, but yeah, this kind of opens up like everything. And I guess like the whole point of LayerZero is that we built this primitive so anyone can build anything on top of it. So it's really up to your imaginations to see where we can go with that. And for this hackathon, if you guys can, try to build on mainnet, just in advance, because it's not everything's always connected. So not all our chains are fully connected in testnet at all times. But yeah, I think I can sum that up. Do you guys have any questions?
You
Sure.
have like an ONFT guide, and like at the bottom of the page is how to deploy the ONFTs from an existing collection to other chains as well. Do you have like a guide for like doing the ONFTs from scratch from a new collection?
Yeah, so we have, most of our guides will actually be to build something from scratch. Like it will be like the ONFT contract that you can deploy. But if you already have a pre-existing thing, we call those adapters.
Yeah.
And the way the adapter will work is instead of minting, burning and minting, it will just be a lockbox in one chain, and on the other chains it'll mint it. If that kind of makes sense. Yeah. So
is that on the website?
it'll be on the website, and if not, if you can't find it, just come to our desk and we can just show you after. Yeah.
Thank you.
Awesome. Yeah. I had a question.
I'm curious, these DVNs, I assume they also are connected with each other and have their own consensus, kind of, or how does it?
No, the DVNs are all like kind of separate entities. Like it could be like anyone, like Google has a DVN with us, Nethermind has a DVN. So these are like anyone can host them. And basically when you're sending messages, we are paying a fee as well, which is calculated through our price feeds, and the DVNs get paid a little bit. So even you can spin up a DVN today if you want. Yeah.
So then I have to trust this one instance of a DVN?
So, but you can configure it. It's modular security, right? So you can have multiple DVNs from different like entities.
Okay.
Yeah.
But if I want to send a message across a chain, let's say, then I send it to one DVN, and that makes sure that it's anchored on the other blockchain, or is it multiple DVNs that kind of?
Yeah. So again, I guess I have to repeat the question here. But the question is, do I need just like, is there only going to be one DVN that's verifying it? But the answer for one specific message. But then that's where your config file kind of comes in. So over here, we use something called simple config generator. But there's actually, if you read the docs, there it'll show you how to expand this out and not use the simple config generator. There you can specify the exact DVNs you want to use, and it could be like 5 DVNs that you'd like to use. So it's really about how you kind of set it up for each message, right? And yeah, and the cost will also go up and down based on how many DVNs you kind of use here. Yeah. Yeah. Any other questions? Cool. Well, we'll be in our booth. Yeah, and yeah. So I hope like this kind of like sparks your imagination. But the idea is like cross-chain anything. We can help you basically build it. Yeah. Cool. Oh, nice.